Okay, in video 2, we're going to look at another situation that might come up algebraically and in trig. So if you look at number 7, you have an x squared term and an x term, but you actually don't have another term. And notice that really these terms do have an x in common. And since there is not a constant term that doesn't have an x, you actually have a greatest common factor. So the way we're going to solve these is using a GCF, greatest common factor. So in this first problem, each of the terms has at least one x, so you're going to factor out the x. And then left over in the first term is going to be a 2x. So basically you divide the first term by x, so you have 2x left over. And in the second term, when you divide the x to the front, you get just square root 2. Okay, equal to 0. So notice it is factoring, but it is a kind of a different kind of factoring. All right, sometimes slightly easier, I think. Now to solve the problem then, we're going to do the same thing. We're going to set x equal to 0, and then we're going to set this factor equal to 0. So the first one is just x equals 0. The second term is 2x minus square root 2 is equal to 0. So add root 2 to both sides. So you get 2x is equal to square root 2. Divide by 2, x is equal to square root 2 over 2. So there's our two solutions for x. All right, in the next problem, I just want to make a note. This problem is a little bit wonky. So we are going to solve it because it has a GCF, but this would not really be the final solution for a problem like this, because notice that you have two variables, x and y. So technically, in order to find the solutions, you would need to have a second equation to tell what the other variable is. So we're just going to do this because it works really well for the trig problem that it is associated with. So I just kind of wanted to set it up for you that way. All right. Now notice that we have 2xy, and that's equal to root 3y. So what we're going to do is get everything to one side. So 2xy subtract square root 3y, set that equal to 0. Okay. And then notice that y is common in both terms. So we're going to say that's y times, then once we divide out y, we get 2x there, and then minus square root 3 there, equal to 0. So we have the choices of y is equal to 0, or we could say 2x minus square root 3 is equal to 0. Add the root 3, so 2x is equal to square root 3, and x is equal to square root 3 over 2. Again, this is not actually the solution, like together root 3 over 2 comma 0. This is one possibility. When y is 0, we actually don't know what x is for this problem. And then if x was root 3 over 2, we don't know what y is. So don't take this as the final answer to a problem like this in algebra. But I only did it because it does, really help us for trig. All right, so moving on to the trig problems. All right, we have 2 sine squared theta minus square root 2 sine theta equals 0. So what I'm noticing is, yes, it's a quadratic. It does not have a term without a sine, so I've got a GCF. Okay, so I'm going to pull the sine of theta out front. Left over would be just 2 sine theta in the first term, and then in the second term, just square root 2. Okay, just like above. Okay, except instead of x, we have sine theta now. All right, so now I have sine theta out here, set that equal to 0. And then I have the 2 sine theta minus square root 2 is equal to 0. And so I would add root 2 and then divide by 2. So I get sine of theta is equal to square root 2 divided by 2. Okay, just like above. Okay. All right, so now I'm going to continue and I'm going to trig. So I have to remember where sine was 0. That, it's not up here, it's over here, right? And then it's also, I think I might be a little bit off the screen, so I'll move this a little bit. It would be sine is 0 here. That's 1 comma 0, sine. and over here, negative 1 comma 0. So I could say 0 and also pi, right? 0 and pi. And if I wanted the general solution, I could actually just say 0 plus pi k, okay? Because I'm just going halfway around to get another solution and then just keep adding pi and I'll get it. For the other one, root 2 over 2, that's sounding very familiar for a reference for sine. Again, in sine, I'm going to be in quad 1 and 2 for positive sine. So that looks like 45 degrees, right? Root 2 over 2. So the reference is 45 degrees or pi over 4. So I've got theta is equal to pi over 4. I could just add on the 2 pi k there. And then also over here, this would be 3 pi over 4 plus 2 pi k. Okay, so I've got my solution 0, pi, pi over 4, and 3 pi over 4, and then of course the generals as well. Okay, circle all the answers. All right, now for number 10, I want you to notice that we've got some issues, definitely have issues. We have sine of 2 theta is equal to square root 3 cosine theta. Okay, so we have one sine and one cosine. Now, these two are not reciprocals of each other, so we can't like change one into the other or anything. But notice that sine of 2 theta is actually a double angle. So you want to think about whether it would be helpful to use the double angle formula. It's not always, but in this case, I think it will be. So the sine of 2 theta in double angle formula would be 2 sine theta cos theta. Okay. So then on the other side, we have root 3 times the cos of theta. Okay. So now it's actually set up, voila, just like number 8. So we are going to notice that there's a cosine on each side. We're going to subtract this term over. So 2 sine theta cos theta minus square root 3 cosine theta is equal to 0. Okay, our GCF are the cos thetas. So we say, okay, cos theta, parentheses, and then we are left with 2 sine theta in the first and minus square root 3 in the second term. Okay. So we get over here, we set this equal to 0, so cos theta equals 0. And then if I solve this for sine theta, I would add 3 and divide by 2. So I would get, well, I'll just write it down. 2 sine theta minus square root 3 is equal to 0. So sine theta is equal to root 3 over 2. Okay. Notice, so I did have some people on the test in a similar problem. Basically right here, they just kind of divided both sides by cosine. And so cosine theta was gone. And when you do that, you do lose the solutions for cosine theta is equal to 0. You still get the sine part right, though. So you get part of it right, but you don't get the entire thing. So the key is to do the GCF factor. Okay. All right, so the cosine is equal to 0 here and here, right? So that's pi over 2 and 3 pi over 2. So let me see if I can't just squeeze this in. That was exciting. Pi over 2 and 3 pi over 2. Okay, and then my general solution then could just be pi over 2 plus pi k. I'm just going halfway around each time. Okay, sorry that got so tiny and squishy, but hopefully you can write it down too. And then when sine is square root 3 over 2, let's see. So I'm in quad 1 and 2 for positive sine. And then I need this opposite side to be root 3. So that's the big side. So this is a reference of 60 or pi over 3. So I've got theta is equal to pi over 3 plus 2 pi k. Or in this quadrant, it's 2 pi over 3 plus 2 pi k. And that's it. So now try some on your own.